What if one moment everything around you just froze? The birds mid-flight, the wind in the trees, even the cup of coffee slipping from your hand, all suspended in perfect stillness. No sound, no movement, just the eerie sensation of being the only thing alive in a world trapped between seconds. This isn't science fiction. There are theories, whispers from the edges of astrophysics and fringe science that suggest such a phenomenon might not only be possible but could already exist, hidden in the fabric of our universe. And the key to unlocking it, something called Alien Entropy Fields Technology. Imagine a force so advanced it doesn't just bend time, it shatters our understanding of it entirely. Picture an ancient, otherworldly mechanism, buried in the cosmos or perhaps even woven into the very laws of physics, capable of halting entropy itself. That's the terrifying, thrilling promise of this technology. Where did it come from? Could it be the work of civilizations far older and more sophisticated than our own? Or is it something even stranger, a natural phenomenon so rare, so inexplicable, that it defies everything we think we know about time, energy, and reality itself? That's the mystery we're diving into today. This isn't just about wild speculation or far-fetched ideas. We're talking about real scientific concepts, bizarre but credible theories that blur the line between physics and the paranormal. From the chilling accounts of astronauts who have glimpsed anomalies in deep space to the mind-bending mathematics that suggest entropy isn't as fixed as we once believed, this journey will take us to the very edge of human understanding. And by the end, you might just question whether time has ever been on our side at all. So buckle up, we're about to explore the impossible. To understand how Alien Entropy Fields Technology could stop time, we first need to grasp the science of entropy, the silent force that shapes everything from melting ice cubes to dying stars. At its core, entropy is a measure of disorder, the universe's slow but inevitable slide from structure into chaos. Think of a sandcastle on the beach. Left untouched, wind and waves will eventually scatter the grains. That's entropy in action. Now scale that up to the cosmic level. Stars burn out, galaxies drift apart, even black holes evaporate over eons. Entropy is why time has a direction, why we remember the past but not the future. It's the reason you can't unscramble an egg or unburn a log. But here's where things get strange. The laws of thermodynamics say entropy always increases. It's as fundamental as gravity. So the idea of halting it, that's like trying to freeze a river mid-flow or stop a bullet in midair. Yet some theories suggest there might be loopholes, ways to manipulate entropy on a quantum level. Imagine a cosmic pause button that could suspend this relentless march toward disorder. What if certain advanced technologies or even natural phenomena could create pockets of reality where entropy doesn't just slow down, it stops entirely? Consider black holes. These gravitational monsters twist space and time so severely that near their event horizons, time appears to stand still from an outside observer's perspective. Could something similar, a controlled distortion of space-time, be the key to freezing entropy? Or perhaps it's even stranger. Some physicists speculate about negative entropy systems where energy flows backward, reversing decay. It sounds like magic, but at the quantum scale, particles routinely defy classical physics, appearing and vanishing in ways that seem to mock our everyday experience. This isn't just theoretical noodling. Experiments with ultra-cold quantum systems have shown particles behaving in ways that appear to momentarily rewind their own entropy. And if that's possible in a lab, who's to say the universe hasn't already stumbled upon stranger mechanisms? After all, nature tends to recycle its most effective tricks. If entropy can be manipulated even for an instant, the implications are staggering. Time itself might not be the rigid, one-way street we assume. It could be more like a tangled web with threads that occasionally snag. So when we talk about alien entropy fields technology, we're not just spinning sci-fi fantasies, we're peering into the fringes of science where the known laws of physics start to fray. Whether it's an ancient alien artifact or a yet undiscovered quirk of the cosmos, the idea forces us to ask, what if entropy isn't the universe's final word? What if, somewhere in the dark between the stars, time has already been stopped waiting for us to find the switch? The sheer scale of what we don't understand about the cosmos is humbling, especially when we consider that humanity's grasp of physics might be like a caveman staring at a smartphone, utterly clueless to the mechanisms at work. If extraterrestrial civilizations exist, and if they've had millions or even billions of years to advance their knowledge, their technology wouldn't just surpass ours. It might operate on principles so foreign they'd seem like sorcery. Take entropy manipulation. To us, reversing decay or freezing time feels impossible, but to a civilization that's cracked the code of quantum gravity or mastered dark energy, it could be as mundane as flipping a light switch. Think about how far we've come in just a few centuries, from horse-drawn carriages to quantum computers, from believing the stars were fixed on a celestial sphere to mapping the ripples of spacetime itself. Now stretch that progress over millennia. As physicist Michio Kaku often points out, a civilization just 1,000 years ahead of us might wield technology indistinguishable from magic. And if they're 1,000,000 years ahead, their capabilities could dwarf our wildest sci-fi. Carl Sagan once speculated that advanced beings might even engineer the very constants of nature, tweaking the speed of light or the strength of gravity like dials on a cosmic control panel. If that's possible, then halting entropy suddenly doesn't seem so outlandish. Consider the hypothetical Kardashev scale, which classifies civilizations by their energy use. A Type 2 civilization harnesses the power of an entire star. A Type 3 commands the energy of a galaxy. At those levels, mastering entropy wouldn't be a parlor trick, it'd be a necessity. Imagine a species that's funneled dying stars into quantum stasis fields or built megastructures that siphon entropy from one region of space to another. They might see time not as a river flowing in one direction, but as a material to be folded, stretched, or even sectioned off like parcels of land. And here's the chilling part, we might already have glimpses of this. Astronomers have detected bizarre cosmic anomalies, stars that dim erratically, galaxies with structures that defy known physics, even strange radio signals that pulse with artificial-seeming precision. Could these be signatures of technologies so advanced they're literally rewriting the rules? Some researchers, like those studying the infamous Tabby star, have openly speculated about alien megastructures. If civilizations can build planet-sized energy collectors, why not entropy-defying machines? Then there's the eerie possibility that we're surrounded by such technology and just can't perceive it. A fish doesn't know it's wet. Would we even recognize a pocket of frozen time if it were right in front of us? Quantum experiments already show particles behaving differently when observed. What if observation itself is the key? An alien device might not look like a gleaming metal orb or a towering monolith. It could be woven into the fabric of reality, invisible until you know how to look. This isn't just about aliens showing off. If entropy control exists, it could solve the universe's ultimate problem, heat death, the slow fading of all energy into a lifeless, uniform void. A civilization facing that inevitability wouldn't just accept it, they'd fight it, and if they found a way to win, that knowledge would be more valuable than anything in existence. So the real question isn't whether such technology is possible, it's whether we're alone in the dark, or if something out there has already cracked the code, leaving us clues in the quiet between the stars. The idea that time might not always flow as smoothly as we assume isn't new. History is littered with bizarre accounts that defy explanation. Take the infamous Philadelphia experiment, a story that's become legend among conspiracy theorists and physicists alike. According to declassified documents and eyewitness testimonies, the USS Eldridge, a naval destroyer, allegedly vanished in 1943 during a secret military experiment aimed at rendering ships invisible to radar. But the strangest part, witnesses claimed the ship didn't just disappear, it reappeared miles away in a matter of seconds, with some crew members fused into the bulkhead or driven insane by the ordeal. The official Navy stance, a hoax, but what if the experiment wasn't about invisibility at all? Some researchers suggest it was an accidental brush with entropy manipulation, a crude attempt to bend spacetime that went catastrophically wrong. The ship didn't teleport, it might have slipped into a pocket of frozen time where the laws of physics unraveled. Then there's the chilling phenomenon of missing time, reported by countless UFO witnesses. Picture this, you're driving down a lonely road at night when a strange light appears overhead. The next thing you know, hours have vanished from your memory, and you're miles further down the highway with no recollection of how you got there. These accounts, often dismissed as sleep deprivation or false memories, share eerie similarities. Could these gaps be more than just mental lapses? If entropy fields can suspend time's flow, even locally, might these witnesses have stumbled into zones where time simply paused for them? Even older records hint at something stranger. Medieval monks wrote of time slips, moments where entire days seem to pass in an instant, or where ancient battles replayed in the sky like ghostly echoes. The Tunguska event in 1908, a massive explosion in Siberia with no crater, has been theorized by some as a natural entropy anomaly, a cosmic glitch where energy briefly reversed its decay. And let's not forget Nikola Tesla's cryptic notes on dynamic gravity, where he claimed to have found a way to alter time's fabric. Was he closer to unlocking entropy's secrets than we realized? Skeptics will argue these are mere coincidences cobbled together by pattern-seeking minds. But the sheer volume of these reports across cultures and centuries raises a haunting question. What if entropy manipulation isn't just a futuristic possibility? What if it's been happening all along, random, uncontrolled, and utterly misunderstood? The universe is under no obligation to make sense to us, and if time can stutter even for a moment, then history might be far stranger than our textbooks dare to admit. Modern physics paints a picture of time that would baffle our ancestors, not as a steady, unchanging river, but as a malleable fabric that warps, twists, and even frays under extreme conditions. At the heart of this revelation lies Einstein's theory of general relativity, which showed us that time isn't absolute, it's elastic. Near a black hole or moving at near light speeds, clocks tick slower compared to those on Earth. Astronauts on the International Space Station experience this firsthand. After 6 months in orbit, they return home having aged slightly less than the rest of us. This isn't science fiction, it's measurable, proven science, but quantum mechanics takes the strangeness further. At the subatomic level, particles don't play by the same rules. Quantum entanglement allows particles to instantaneously influence each other across vast distances, seemingly defying time's flow. Then there's the quantum Zeno effect, where observing a particle repeatedly can freeze its state almost as if time stops for it. In labs, scientists have used ultra-cold atoms to create time crystals, structures that repeat not in space but in time, forever oscillating without energy input. These aren't just curiosities, they're hints that time might be more like a material we can sculpt than an immutable force. Particle accelerators offer even wilder possibilities. When protons collide at near light speed in the Large Hadron Collider, their interactions occur in time frames so short they're measured in septillionths of a second. In these extreme conditions, the very concept of cause and effect blurs. Some theorists speculate that if we could harness energies 1 trillion times greater, perhaps with technology far beyond ours, we might create localized regions where time's arrow bends backward. Even relativity's equations admit solutions where closed time-like curves loops in spacetime. could allow time travel. Physicist Ron Mallett has spent decades working on a laser-based device he believes could twist spacetime into such a loop. Most of his peers are skeptical, but the math holds up, and if the math allows it, nature might too. The most tantalizing clue comes from black holes. At their event horizons, time appears to stand still from an outsider's perspective. Cross that boundary, and the laws of physics as we know them break down. Some models suggest that inside a rotating black hole, spacetime could churn so violently that it forms tunnels to other times or universes. Could an advanced civilization have learned to mimic these conditions artificially? To create bubbles of frozen time without the crushing gravity? What's clear is this: the universe is far weirder than we imagined. Time isn't the rigid scaffold we thought. It's a dynamic, twistable thing, and if we're brave enough to follow the science wherever it leads, we might just find that stopping time isn't magic. It's physics waiting to be discovered. Picture a civilization that doesn't just harness energy, but sculpts the fabric of reality itself. To build technology capable of halting time, they'd need to master three radical ingredients: negative energy, exotic matter, and space-time curvature. Let's break down how these pieces might fit together in an alien entropy field generator, a theoretical machine that could freeze decay at its source. Negative energy sounds like science fiction, but it's a real concept in quantum physics. In empty space, particles flicker in and out of existence, creating a seething quantum foam. Normally, these particles annihilate each other instantly, maintaining equilibrium. But certain configurations, like the Casimir effect, where two metal plates placed nanometers apart suppress particle fluctuations, can create regions with less energy than empty space. This is negative energy. Now imagine scaling that up. A civilization advanced enough to generate vast fields of negative energy could use it like cosmic glue, counteracting entropy's relentless push toward disorder. It'd be like pouring anti-gravity into the gears of time itself. Then there's exotic matter, hypothetical particles with bizarre properties like negative mass. While we've never observed it, equations in general relativity allow for its existence. Alien engineers might cultivate exotic matter like we farm crops, growing it in quantum fields or harvesting it from the turbulent edges of neutron stars. This material would be the backbone of their entropy-defying device. Picture it woven into a lattice surrounding a target area, its negative mass repelling gravity's pull. The result, a bubble where space-time doesn't just curve, it folds. Inside this pocket, the usual arrow of time could twist into a loop, freezing entropy in place like a bug in amber. But the real magic happens when these ingredients combine with controlled space-time curvature. Einstein showed us that mass bends spacetime like a bowling ball on a trampoline. An alien device might take this further, using precise arrangements of exotic matter and negative energy to create ultra-precise warps. Think of it like origami for reality. By folding spacetime just right, they could isolate a region where entropy's usual rules don't apply. From outside, it might look like a shimmering sphere where rain hangs motionless midair. From inside, time would simply stop. No decay, no change, just perfect stillness. The most mind-bending possibility: these fields might already exist naturally. Quantum physicists have theorized about false vacuum bubbles, regions where the fundamental constants of physics differ from our universe. Some could have lower entropy by default. If an alien civilization learned to create or relocate these bubbles, they'd essentially carry pockets of frozen time with them like cosmic refrigerators. Now consider the energy requirements. To manipulate spacetime on this scale would demand power sources beyond anything we know, perhaps tapping into the spin of entire neutron stars or harvesting dark energy directly. That's why this technology likely wouldn't belong to a young civilization like ours. It'd be the hallmark of a culture that's transcended planetary limits, treating the universe itself as raw material. What would they use it for? Imagine preserving irreplaceable artifacts indefinitely, or placing wounded beings in stasis until medicine advances enough to heal them. Entire worlds might be suspended at their peak to avoid cosmic disasters, or perhaps they'd weaponize it, freezing enemy fleets mid-battle like insects in resin. The terrifying beauty of this idea is that we might never recognize such technology if we encountered it. A functional entropy field could appear as nothing more than a patch of slightly warped space, indistinguishable from natural phenomena until you crossed its boundary and realized too late that time no longer moves for you. That's the paradox of advanced physics. The most powerful technologies might leave the faintest traces, hiding in plain sight until we're wise enough to see them. Eyewitness accounts of time behaving strangely aren't just the stuff of late-night conspiracy shows. They come from pilots, military personnel, and ordinary people with no reason to lie. Take the infamous 1976 Tehran UFO incident, documented by both Iranian fighter jets and civilian witnesses. Two F-4 Phantom jets scrambled to intercept a brilliant, pulsing object hovering over the city. As one pilot closed in, his instruments malfunctioned and his radio dissolved into static. Later, he'd describe a surreal sensation, like the universe had hit pause. His watch, along with his wingman's, showed a 20-minute discrepancy post-encounter, despite synchronized timing before takeoff. Even the tower's logs confirmed the gap. Coincidence, maybe, but when multiple trained observers, people whose lives depend on precise timekeeping, report identical anomalies, it's harder to dismiss. Then there's the baffling case of Frederick Valentich, a young Australian pilot who vanished in 1978 while reporting a strange craft mirroring his movements over the Bass Strait. His final radio transmission captures his rising panic. It's not an aircraft, but the eeriest detail. Listeners swear they heard an unnatural metallic scraping noise through the radio, as if time itself had glitched, blending moments that shouldn't overlap. No wreckage was ever found. Skeptics argue he became disoriented and crashed, but why would disorientation warp audio recordings? Civilian stories are just as chilling. In 1997, dozens of witnesses in Phoenix reported a massive V-shaped object silently drifting overhead. Some swore their digital watches reset or froze during the event. One man, a retired Air Force mechanic, described stepping outside to see the stars blink out as if the sky had been unplugged. When time apparently resumed, his grill left burning, had gone cold, the charcoal untouched. Physics says heat doesn't vanish into thin air, but if entropy stalled locally, even briefly, energy transfer would halt too. Of course, psychology offers alternative explanations: mass hysteria, misinterpreted natural phenomena, or the brain's tendency to fill gaps during stress. Memory is famously unreliable, but when accounts align across cultures and decades, untrained observers describing the same impossible details, it's worth asking if we're missing something. Neurologists know certain seizures can distort time perception, and electromagnetic fields near UFOs might affect brain function. Yet that doesn't explain physical anomalies like stopped watches or cold engines. Perhaps the most compelling cases involve multiple witnesses independently experiencing missing time. In 1961, Betty and Barney Hill's alleged abduction included 2 hours they couldn't account for later, recovered under hypnosis with matching details. More recently, a group of hikers in Norway's Hesdalen Valley described watching a floating orb before realizing their cameras had captured 3 extra hours of footage showing nothing but static. Timestamps don't hallucinate. Critics argue these stories thrive on ambiguity, that without physical evidence, they're just modern folklore. But when pilots risk careers to speak up, when radar corroborates visual sightings, and when the same anomalies surface in classified government reports, the line between myth and mystery gets blurry. Maybe these witnesses stumbled into something science hasn't named yet: glitches in the cosmic code where time doesn't play fair. Or maybe, just maybe, they glimpsed the unthinkable, a technology that treats entropy like an old clock, winding it tight or letting it stop altogether. Government secrecy around advanced technology is nothing new. Just look at the Manhattan Project, where thousands worked on the atomic bomb in total silence. But what if some classified programs go even further, exploring physics so radical it borders on science fiction? For decades, whispers have swirled about covert research into time manipulation, possibly even with reverse-engineered alien tech. The evidence is scattered but compelling. Start with the Pentagon's Advanced Aerospace Threat Identification Program, or ATIP. Officially, it investigated UFOs from 2007 to 2012. But insiders like former program director Luis Elizondo have hinted at stranger truths. In interviews, he's described recovered materials with metamaterial properties, alloys that could manipulate electromagnetic fields in ways defying known science. Could such materials interact with spacetime itself? One ATIP contractor, physicist Hal Puthoff, has openly studied zero-point energy, a quantum phenomenon some theorists link to entropy manipulation. Coincidence, maybe, but when you connect the dots, a pattern emerges: the military's keen interest in technologies that bend the rules of reality. Then there's the infamous Wilson-Davis memo, a leaked document detailing a 1997 meeting between Admiral Thomas Wilson and aerospace engineer Dr. Eric Davis. Wilson, then Deputy Director of the Defense Intelligence Agency, allegedly learned of a classified corporate program studying recovered off-world vehicles. According to the memo, these artifacts exhibited propulsion systems that distorted local spacetime. The implications are staggering. If true, it suggests private entities, not just governments, might possess physics-shattering tech locked behind layers of secrecy. Whistleblowers add fuel to the fire. Bob Lazar, perhaps the most controversial figure in UFO lore, claimed to have worked at S4, a clandestine site near Area 51, where he reverse-engineered alien craft. His descriptions of gravity, wave propulsion, and element 115 sound outlandish, yet oddly align with later theoretical work on super-heavy elements and warp drives. Even more intriguing, Lazar reported anomalous time dilation effects during test clocks running at different rates near the crafts. Skeptics dismiss him, but his exacting details about S4's location and procedures were later corroborated by declassified documents. Declassified records from the Cold War reveal even earlier suspicions. Project Stargate, the CIA's psychic espionage program, explored remote viewing of distant locations. While most dismiss it as pseudoscience, some sessions allegedly described future events with eerie accuracy, as if viewers glimpsed timelines where time's flow wasn't fixed. Then there's the 1989 case of Soviet scientist Anatoly Bugorsky, who survived a particle accelerator beam to the head and claimed to experience time in fragments afterward. Coincidentally, around the same period, the KGB reportedly investigated chronal anomalies in Siberian laboratories. The most tantalizing clue comes from a 2017 New York Times exposé. Buried in the article was a throwaway line about a Pentagon-funded study examining warp drives, wormholes, and extra dimensions. The study's lead, Dr. Davis, later confirmed they'd analyzed theoretical ways to engineer spacetime. When pressed, he admitted some concepts were inspired by UFO reports. That's a jaw-dropping admission. Official research into Star Trek-level tech, nudged by encounters we still don't understand. So what are we to make of all this? At minimum, it suggests governments take these ideas seriously enough to spend millions investigating them. At maximum, well, if even a fraction of these claims hold weight, someone somewhere might already be tinkering with time itself. And that raises a darker question. If such tech exists, who gets to control it, and what happens when they do? What if consciousness isn't just a passenger in the flow of time, but the pilot? For decades, scientists have grappled with the hard problem of consciousness. how subjective experience arises from mere matter, but a more radical question lurks in the shadows. Could consciousness actually influence the fabric of reality itself? Some theories suggest that advanced alien civilizations might have cracked this code, using mental energy as a tool to manipulate entropy fields and, by extension, time. Consider the eerie phenomenon of time dilation during life-threatening situations. Survivors of car crashes or falls often report events unfolding in slow motion, as if their perception of time stretched like taffy. Neuroscientists chalk this up to the brain's adrenaline-fueled hyperfocus. But what if there's more to it? Studies at the Human Performance Laboratory in Texas found that subjects in meditative states could consistently underestimate or overestimate elapsed time by staggering margins, sometimes perceiving minutes as hours. Even stranger group meditation experiments, like the 1993 Washington, D.C. Maharishi effect, correlated with temporary drops in local crime rates, as if collective consciousness briefly warped statistical probabilities. Then there's the Princeton Engineering Anomalies Research Lab's decades-long work on mind-matter interaction. Their experiments showed human intention subtly affecting random number generators, a hint that consciousness might nudge physical systems. Scale that up to an alien civilization with millennia of mental discipline. Imagine beings who have honed their minds to focus intention like a laser, bending quantum fluctuations to their will. If a single meditator can alter their perception of time, what could a billion synchronized minds achieve? The link grows stranger when examining psychedelics. Psilocybin and DMT users frequently report time collapsing entirely, experiencing eternity in an hour, or living entire lifetimes between heartbeats. Research at Imperial College London found these substances reduce activity in the brain's default mode network, the neural circuitry responsible for our sense of linear time. Strikingly, quantum physicists note similarities between these brain states and the behavior of particles at microscopic scales, where cause and effect blur. Could advanced aliens have bioengineered ways to induce such states at will, using consciousness as a dial to tweak entropy? Theoretical frameworks like ORCH, or proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hamroff, suggest quantum processes in brain microtubules might bridge consciousness and fundamental physics. If true, a sufficiently advanced mind could interact directly with spacetime's underlying structure. Picture an alien species that's evolved beyond biological limits, their thoughts resonating at frequencies that entangle with quantum fields. To them, freezing time might be as natural as breathing is to us. Perhaps the most unsettling implication lies in quantum observer effects, where particles behave differently when measured. Some interpretations argue consciousness causes this collapse from probability to reality. Now imagine a civilization that's weaponized this principle, focusing collective awareness to lock regions of spacetime into desired states. Historical accounts of shamans or oracles stopping the sun might be garbled records of such technology in action. This isn't just philosophical speculation. Declassified CIA files from the Stargate project include reports of remote viewers accurately describing future events, hinting that trained minds might access non-linear time. Meanwhile, the Global Consciousness Project's network of random number generators spikes during global crises, as if mass awareness briefly bends reality's rules. So when we ask how aliens might control entropy fields, we're really asking about the universe's deepest secret, the role of mind in shaping existence. If consciousness is the canvas, perhaps time is just the brushstroke, and somewhere in the cosmos, others might have mastered the art. Stopping time sounds like the ultimate power until you realize it might unravel reality itself. The moment you freeze a single instant, you're playing with fire. Causality, the unbreakable chain of cause and effect that keeps the universe logical, starts to fray. Think of it like pulling a single thread from a tapestry. At first, nothing seems wrong, but soon the entire image collapses into chaos. Take the classic grandfather paradox from time travel stories. If you go back and prevent your grandfather from meeting your grandmother, you'd never be born, which means you couldn't have traveled back to stop them. It's a logical impossibility. Now apply that to frozen time. If you pause reality to change something in that suspended moment, what happens when time restarts? Does the universe remember the original timeline, or does it rewrite itself around your actions? Theoretical physicists call this a causality violation, and the equations suggest it could create catastrophic feedback loops, ripples in space-time that amplify until reality becomes a hall of mirrors. Science fiction loves exploring these nightmares. In the Twilight Zones, a kind of stopwatch, a man freezes time but accidentally smashes his only tool to restart it, trapping himself and everyone else in an endless, silent limbo. Even Superman's iconic time-reversing flight around the Earth in the 1978 movie raises questions. If he undid Lois Lane's death, did he also erase every other event in that time frame? The stories gloss over the collateral damage, but physics wouldn't be so forgiving. Real science backs up these fears. Quantum mechanics has its own version of paradoxes, like the bootstrap paradox, where information or objects exist without any origin. Imagine finding a time-stopping device in your lab, and later you send that same device back in time to your past self. Who built it? No one, it just is. Now scale that up. If an alien entropy field freezes time in a region, then restarts it with slight changes, does the universe need to reconcile the altered version with the original? Some models suggest this could spawn parallel timelines, branching realities where contradictions resolve themselves by splitting existence into fragments. The most chilling possibility comes from black hole physics. Near a singularity, general relativity predicts closed time-like curves, loops where time circles back on itself. If you could artificially create such a loop by halting entropy, you might trap a piece of reality in an inescapable cycle. Picture a planet frozen mid-explosion, reliving the same nanosecond forever. Or worse, a civilization that pauses time to avoid a disaster, only to discover they can't unpause it, locking themselves in a moment they were trying to escape. Humanity's grasp of time is still primitive. We think of it as linear because that's all we've ever experienced. But if entropy fields exist, they could reveal time as something far stranger, a fragile, tangled web where every intervention leaves permanent scars. The aliens who mastered this technology wouldn't just be advanced, they'd be walking a knife's edge between godhood and annihilation. Why would an advanced civilization bother to stop time in the first place? The answer might lie in the same forces that drive all intelligent life: survival, curiosity, and the relentless pursuit of control over an unpredictable universe. Picture a species billions of years older than ours, facing existential threats we can barely comprehend. Heat death looms for everyone, even gods. If entropy is the universe's slow unraveling, then mastering its flow wouldn't just be a technological achievement. It'd be the ultimate act of self-preservation. Consider the most straightforward motive: staving off extinction. A dying civilization might freeze time around their home star, creating a pocket of suspended entropy to outlast the cosmos' decay. Imagine sealing an entire planet in a timeless bubble, preserving its ecosystems and cities perfectly while the outside universe ages into dust. It's the cosmic equivalent of hitting snooze on doomsday. Or perhaps they'd use localized fields to protect interstellar arcs during long voyages, effectively skipping millennia of travel by pausing their passengers' perception of time. Suspended animation is child's play compared to halting entropy itself. Then there's the darker possibility: control. Time manipulation would be the ultimate weapon. An aggressor species could freeze enemy fleets mid-attack, leaving them drifting helplessly in a silent void while their civilization falls. Entire battles might be won before the first shot is even perceived. History itself could be rewritten by pausing moments of crisis and altering outcomes without witnesses. Imagine a galactic empire erasing rebellions by trapping dissidents in loops of frozen time, invisible prisons where a single second stretches into eternity. Power doesn't get more absolute than that, but not all motives need be selfish. Advanced beings might wield this technology as guardians, not conquerors. Picture a civilization that detects an asteroid hurtling toward a pre-industrial planet. Rather than intervene visibly and risk cultural contamination, they could freeze the threat in space, letting the impactor hang motionless until the natives develop the tech to deflect it themselves. Or consider a universe where entropy fields act as emergency brakes for natural disasters. Supernova paused mid-explosion, black holes stabilized before they devour star systems. Such acts would leave no trace beyond the inexplicable salvation of doomed worlds. Experimentation can't be ruled out either. A species that's transcended biological limits might treat time as a laboratory. Entire star systems could become test subjects for entropy manipulation, observing how life evolves when freed from time's constraints, or whether consciousness persists in timeless voids. The most unsettling thought: we might already be part of such an experiment. If pockets of altered entropy exist, how would we know if we're inside one? There's also the terrifyingly mundane resource management. Advanced civilizations might pause time to store energy or matter indefinitely, creating cosmic warehouses where fusion reactions hover mid-burn or antimatter sits perfectly contained. Need a star's worth of fuel 10 billion years later, just unfreeze a slice of one. The motives spiral wilder the deeper you look. Maybe time manipulation is trivial for them, a tool as commonplace as electricity is to us. Or perhaps they've glimpsed something in the fabric of reality that makes entropy control not just useful but inevitable. One thing's certain: a civilization that commands time doesn't think like we do. Their reasons might be as incomprehensible to us as a farmer's crop rotation would seem to a bacterium. And that's the real chilling thought: not that they could stop time, but that they'd have purposes we can't even begin to fathom. The sheer ambition of replicating alien entropy field technology lies beyond our current grasp, but not necessarily beyond our future. Right now, humanity stands where we once did before splitting the atom or decoding DNA, on the precipice of a revolution we can't yet fully envision. The obstacles are staggering, but so were the challenges of spaceflight to the Wright brothers. The first hurdle: energy. To manipulate spacetime on the scale required, we'd need power sources that dwarf anything we've built. Fusion reactors like ITER in France might inch us closer, but even they pale in comparison to the theoretical energy needed to bend entropy. Some calculations suggest we'd require the total output of a star just to create a time-stopping field the size of a refrigerator. Then there's the problem of exotic matter. The equations of general relativity allow for materials with negative mass, but we've never observed them naturally. Laboratories like CERN hunt for clues in particle collisions, while quantum physicists explore metamaterials that bend light in unnatural ways. Imagine layering these with superconducting lattices cooled to near absolute zero, conditions where quantum effects dominate. It's not impossible, just impossible today. Projects like DARPA Breakthrough Propulsion Physics program hint at military interest in these frontiers, studying warp bubbles and Casimir effects that flirt with spacetime manipulation. But turning theoretical sketches into working machines, that's a leap we haven't made yet. Ethical dilemmas add another layer of friction. Even if we crack the physics, should we? History shows how disruptive technologies, nuclear weapons, AI, can outpace our wisdom to wield them. A working entropy field device could be weaponized instantly, freeze a rival nation's missiles mid-launch, or lock enemies in timeless prisons. Worse, accidental misuse might unravel causality itself. The same scientists exploring these possibilities often warn that meddling with time's flow could spawn paradoxes capable of erasing events from history or creating branching realities where consequences spiral beyond control. Yet hope glimmers in cutting-edge experiments. Researchers at the University of Queensland have simulated time crystals, structures that repeat in time rather than space, defying entropy's usual rules. Teams at Stanford manipulate quantum entanglement to effectively rewind particle states, a microscopic reversal of decay. These are baby steps, but they prove entropy isn't the immutable force we once thought. Perhaps the most realistic path forward isn't brute force replication, but collaboration with AI. Machine learning already accelerates drug discovery and material science. Could it someday solve the equations for entropy control? A partnership between human intuition and artificial superintelligence might bridge gaps too vast for either alone. The truth is, we're playing a long game. Alien civilizations, if they exist, likely had millions of years to stumble upon these breakthroughs. For now, our role might be to lay the groundwork, probing quantum anomalies, mapping spacetime's quirks, and most crucially developing the wisdom to handle technologies that blur the line between power and peril. Because the day we finally pause time, we'd better be certain we know how to start it again. Freezing time sounds like the ultimate pause button until you consider what it might do to the living things caught in its grip. Picture a hummingbird suspended mid-flutter, wings frozen like glass, or a sprinter's muscles locked in mid-stride. At first glance, it's a breathtaking tableau. But zoom into the cellular level and the questions multiply. Would neurons still fire in a brain trapped outside time? Would a single frozen heartbeat stretch into an eternity of stillness? The answers might lie where biology collides with physics in ways we're only beginning to understand. Take metabolism, the constant churn of chemical reactions that keep organisms alive. In normal time, cells break down glucose, repair DNA, and shuttle ions across membranes in a flurry of activity. But in a frozen entropy field, would these processes halt completely or merely slow to imperceptible levels? Cryonics research offers clues. When scientists vitrify organs for transplant storage, they replace blood with antifreeze solutions to prevent ice crystals from shredding cell structures. The result isn't true time stoppage, but a close analog. Biological activity drops to near zero. Yet even in this state, quantum effects persist. Electrons still orbit atomic nuclei, and proteins vibrate faintly with residual energy. This suggests that absolute stasis might be impossible, only an extreme slowdown. Consciousness adds another layer of mystery. Patients revived from hypothermic states, like the Swedish woman who survived 80 minutes without a heartbeat after falling into icy water, often report no memory of their dead time. But what if time froze around a conscious mind? Quantum biology theories propose that microtubules in brain cells might harness quantum vibrations to generate awareness. If so, halting entropy could sever the link between thought and perception, leaving a mind awake but utterly disconnected, a prisoner in an unchanging moment. The horror isn't just being frozen, it's being frozen while still aware. Then there's aging. Telomeres, the protective caps on chromosomes, shorten with each cell division, a biological clock ticking toward death. But in suspended time, would cells still count those divisions? Tardigrades, microscopic extremophiles that survive deep space by entering cryptobiosis, pause their cellular aging entirely when dehydrated. For them, decades pass in an instant. An alien entropy field might function similarly, pressing pause on senescence, but restart time after millennia, and the implications grow eerie. A human unfrozen after 10,000 years would wake to find their body unchanged, while the universe around them had crumbled into cosmic dust, the darkest possibility. Irreversible damage. Even if cells survive frozen time, entropy's arrow might still lurk beneath the surface. DNA accumulates random mutations from background radiation, a process that wouldn't stop just because macroscopic time did. Over eons, these microscopic errors could accrue, rendering a perfectly preserved body riddled with unseen genetic chaos. It's the ultimate cosmic irony, stopping time to cheat death, only to have decay sneak in through quantum backdoors. Perhaps this explains why advanced civilizations would treat entropy manipulation with caution. Mastering time doesn't just mean controlling clocks, it means rewriting the rules of life itself. And until we understand how consciousness, biology, and quantum physics intertwine, pressing that pause button remains a gamble with stakes we can't even calculate. Deep in the Ural Mountains of Russia, where the taiga stretches unbroken for thousands of miles, loggers from the village of Kedrovka stumbled upon a sight that defied every law of nature. On the morning of January 17, 1993, a team led by forester Anatoly Karpov entered a familiar stretch of pine forest only to find it utterly, impossibly still. Not the quiet of a windless day, but the absolute stillness of a photograph. Snowflakes hung motionless in the air like suspended dust. A woodpecker mid-strike clung frozen to a tree, its wings stiff as glass. Most disturbing, the team's breath stopped forming vapor clouds the moment they stepped past an invisible boundary. Their radios emitted only static, and watchers refused to advance. For 3 hours and 42 minutes by their estimation, they documented the anomaly before, without warning, time resumed. Snowflakes fell, the woodpecker's beak struck bark, and the forest exhaled as if nothing had happened. Official reports dismissed it as mass hysteria triggered by extreme cold, but the environmental data tells a stranger story. Meteorologists confirmed the temperature inside the frozen zone measured a consistent 0 degrees Celsius, impossible given the surrounding -20 conditions. Soil samples later analyzed by Moscow State University showed bizarre isotope ratios, as if the area had been isolated from Earth's natural radioactive decay. Even stranger, the affected pines grew 30% faster in subsequent years, their rings revealing a cellular memory of the event. Witness testimonies collected by paranormal investigator Dr. Irina Volkova share eerie consistencies. Multiple loggers described a pressure like diving deep underwater upon entering the zone. One man, Sergei Malikov, claimed his fingers passed through a suspended snowflake without disturbing it, like touching a ghost. Another reported seeing his companion's movements slow to stop mid-sentence, his last word stretched into an endless hum. These accounts mirror modern quantum experiments where supercooled atoms enter time crystal states, repeating patterns in time rather than space. Scientific explanations range from plausible to fantastical. Geologists point to rare earthquake lights, electromagnetic pulses preceding seismic activity that might briefly warp local spacetime. Others suggest a natural Casimir effect where the forest's geometry accidentally created quantum vacuum conditions capable of slowing entropy. Then there's the more unsettling theory. The site intersected with an artificial entropy field, perhaps from a malfunctioning device buried deep underground or something scanning the area from above. Satellite imagery later revealed a perfect circle of accelerated growth where the frozen zone had been, as if the trees were catching up on missed time. The most haunting detail comes from indigenous Mansi tribespeople who avoided that forest long before the incident. Their legends speak of sleeping places where the world becomes thin and spirits walk between moments. Whether ancient wisdom or chilling coincidence, one thing's clear: the Urals hold secrets that challenge our understanding of time itself, and whatever happened that day didn't just freeze a forest. It froze our certainty that time flows the same for everyone, everywhere. Ancient myths often feel like distorted echoes of impossible truths, stories too strange to be pure invention. Take Kronos, the Greek titan who devoured his children to prevent his own downfall. More than just a cautionary tale, his legend carries eerie parallels to entropy itself, the unrelapsing consumption of order into chaos. But here's the twist. In some traditions, Chronos didn't just symbolize time's passage, he controlled it. Orphic hymns describe him holding a serpent coiled around an egg, a metaphor some scholars interpret as freezing the cosmic cycle. Could this be a garbled memory of entropy manipulation technology witnessed by ancient cultures? Hindu cosmology deepens the mystery. Lord Vishnu rests on the serpent Ananta, whose name means endless, a being existing outside time. During the cosmic dissolution called Pralaya, Vishnu enters a state of suspended animation, preserving the universe's blueprint until rebirth. The descriptions are shockingly precise: a sea of milk where nothing decays, where energy neither scatters nor fades. Modern physics might call this a zero-entropy field. Even the Vedas' cyclical time concept, with days of Brahma lasting billions of years, mirrors theories of entropy reversal in oscillating universe models. Similar threads appear globally. The Norse god Odin could plunge Midgard into a timeless sleep with his spear. The Dogon people of Mali, whose astronomical knowledge baffled anthropologists, spoke of nomo-amphibious beings who stopped the sun to teach humans. Most striking, these myths often link time manipulation to celestial visitors. The Babylonian Apkallu, fish-headed sages from the sea, allegedly taught humanity secrets that included binding the hours. Ancient astronaut theorists argue these weren't metaphors but fractured accounts of contact with advanced beings wielding entropy-defying tech. Archaeological oddities fuel the speculation. The Antikythera mechanism, a 2,000-year-old Greek device tracking planetary movements with clockwork precision, hints at lost mechanical sophistication. But what if it was a pale imitation of something far older? The Delhi iron pillar, rust-resistant for 16 centuries, defies material science much like a material preserved in a time dilation field. Even the Great Pyramids' near-perfect alignment and anomalous inner chamber temperatures have spawned theories of ancient energy manipulation, perhaps accidental reactivations of buried alien technology. Critics dismiss these connections as pattern-seeking, but the consistency is haunting. Cultures separated by oceans and millennia shouldn't share such specific motifs of frozen time and star-born teachers unless witnessing something extraordinary. Maybe the gods never were divine. Maybe they were explorers from a civilization that mastered entropy, leaving behind myths as their only fingerprints. And if so, their greatest secret, how to pause time itself, might still be hidden in plain sight, woven into stories we've told for thousands of years without understanding why. Quantum entanglement, the bizarre phenomenon where particles become inextricably linked across vast distances, might hold the key to understanding how time itself could be manipulated. Picture two electrons spinning in perfect sync, separated by light years. Change the spin of one, and the other instantly mirrors that change, as if space between them doesn't exist. Einstein called this spooky action at a distance, but what if that spookiness isn't just about space? What if entanglement also dances with time? At the quantum level, particles don't just ignore distance, they seem indifferent to time's arrow. Experiments have shown entangled particles responding to each other faster than light could travel between them, hinting at a deeper layer of reality where cause and effect aren't strictly linear. This raises a tantalizing possibility. If entanglement can bypass space, could it also bypass entropy? Imagine an advanced civilization engineering entangled systems to freeze one particle, forcing its partner to halt its own decay instantaneously, no matter how far apart they are. It'd be like flipping a switch in Andromeda and watching a lamp in your living room dim in perfect unison. The math gets even stranger. Quantum theory allows for retrocausality, where future events influence the past. In labs, scientists have demonstrated delayed choice experiments, where decisions made after a particle's measurement appear to alter its earlier state. Now scale that up. If entangled particles can transmit quantum states backward through time, could a time-stopping signal be sent? not just across space but across moments. A civilization mastering this might not need to physically freeze time. They could entangle entire regions of space-time, creating a network where entropy's flow is negotiated like a cosmic trade agreement. Consider the implications for communication. Normal signals degrade over distance limited by light speed, but entangled systems could transmit information instantaneously, effectively sidestepping time's flow. An alien species might use entangled particles as a quantum telegraph, sending commands to entropy field generators scattered across galaxies, all synchronized to pause reality in unison. This wouldn't just defy physics as we know it, it'd rewrite the rules of causality itself. Yet the biggest enigma lies in the nature of observation. Quantum systems remain in superposition, existing in multiple states at once until measured. The act of observation collapses these possibilities into a single outcome. Now apply this to time manipulation. If consciousness plays a role in shaping quantum reality, could an advanced being observe a moment into freezing? It's a dizzying thought. Entropy fields might not be mechanical at all, but perceptual, activated by minds attuned to quantum subtleties we're only beginning to glimpse. The universe, it seems, keeps its most profound secrets written in entanglement's cryptic language. And if we ever learn to read it, we might find that stopping time isn't about forcing the clock's hands still, but realizing they were never moving to begin with. Black holes aren't just cosmic vacuum cleaners, they're nature's most brutal experiments in entropy manipulation. At the edge of a black hole's event horizon, time doesn't just slow down. From an outside observer's perspective, it grinds to a halt. A clock falling toward that boundary would tick slower and slower until its hands freeze entirely, as if the universe itself hit pause. This isn't science fiction. It's the stark prediction of Einstein's general relativity, proven by observations of stars orbiting Sagittarius, a star, the supermassive black hole at our galaxy's core. Their light stretches into infinite redness as they near the point of no return, a phenomenon called gravitational time dilation. But here's the twist: the same forces that make black holes entropy engines might also hold the blueprint for artificially controlling time. Stephen Hawking's groundbreaking work revealed something even stranger. Black holes aren't eternal. They slowly leak energy, Hawking radiation evaporating over eons. This means they're not just freezing time, they're fighting entropy's tide from within. Imagine a paradox where a region of space halts time's flow while simultaneously decaying. It's like a river that stops moving yet still erodes its banks. Hawking's calculations showed that black holes possess temperature and entropy, linking them irrevocably to thermodynamics. But what if their ability to warp space-time isn't just a destructive force? What if it's a template? Consider the math. The equations describing a black hole's space-time curvature could, in theory, be reverse engineered. Instead of a singularity crushing matter into oblivion, you might create a controlled bubble where space-time folds gently, suspending entropy without annihilation. Think of it as the difference between a hurricane and a wind turbine. Both harness the same physics, but one destroys while the other powers civilizations. Advanced aliens might have cracked this distinction, using black holes as textbooks to design devices that mimic their time-bending effects without the apocalyptic side effects. The most tantalizing clue lies in rotating black holes, or Kerr black holes. Their spin drags space-time around them like a whirlpool, creating regions called ergospheres where nothing can stand still. Matter entering an ergosphere gets slingshotted with such force that it could, theoretically, escape with more energy than it entered. This negative energy phenomenon mirrors the Casimir effect in quantum physics, where vacuum fluctuations can produce regions of negative energy, precisely the ingredient needed to stabilize an artificial entropy field. A civilization that mastered this could, in essence, carve out pockets of reality where time's arrow bends to their will. But the real shocker, black holes might not be the only natural entropy manipulators. Neutron stars, magnetars, even certain quantum vacuum states exhibit spacetime distortions that hint at smaller-scale time anomalies. The universe could be littered with naturally occurring time traps, waiting for a species clever enough to adapt them. Hawking once mused that advanced beings might harness mini black holes as energy sources. Perhaps they'd go further, using them as lenses to focus time itself. This isn't just theoretical noodling. Labs today are already simulating black hole conditions using Bose-Einstein condensates and metamaterials. In 2019, scientists created an artificial event horizon in fiber optics, observing Hawking-like radiation. These experiments are child's play compared to what a Type 3 civilization might achieve, but they prove a crucial point. The universe's most violent phenomena could become tools. And if black holes are nature's entropy factories, then the technology to stop time might not be buried in alien blueprints. It's written in the cosmic landscape, waiting to be read. What if our entire universe isn't just governed by entropy, but debugged by it? Simulation theory, the mind-bending hypothesis that reality might be an artificial construct, takes on eerie new dimensions when paired with the concept of alien entropy fields. Philosopher Nick Bostrom's classic paper argues there's a statistically significant chance we're living in a simulation created by an advanced civilization. But here's the unsettling extension. If they can build universes in their equivalent of computer code, why wouldn't they have pause buttons? Think of how we interact with virtual worlds today. Video games have save states where progress freezes. AI training environments can rewind milliseconds to test different outcomes. Now scale that up to a civilization with quantum computing capabilities beyond our imagination. Their simulations wouldn't just run linearly, they'd have debugging tools. An entropy field generator might be their version of clicking breakpoint, suspending their created reality to examine glitches or rerun scenarios. The implications are staggering. Those moments when time seems to stutter, the missing minutes reported by UFO witnesses, the frozen forest in the Urals, could be literal system pauses, instances where the simulators halt their experiment to adjust parameters. Bostrom's trilemma suggests one of three possibilities. Civilizations like ours never reach post-human status. They choose not to run ancestor simulations, or we're almost certainly living in one. But what if there's a fourth option, that the simulations aren't historical recreations, but experimental frameworks where time itself is a variable they manipulate? Indigenous cultures worldwide describe dreams of worlds between worlds where time flows differently. Modern physics entertains multiverse models where fundamental constants vary across realities. These could be cultural memories or intuitive grasps of a simulated multiverse where entropy isn't fixed but adjustable. The technological requirements for such control are incomprehensible but not impossible. Our own quantum computers already manipulate qubits in states of superposition, effectively exploring multiple timelines simultaneously. A post-singularity civilization might encode entire universes on Planck-scale quantum foam, with entropy fields acting as error correction protocols. Glitches in these systems could explain paranormal phenomena, ghosts as residual data from rewound timelines, déjà vu as memory leaks between simulation cycles. Even the Mandela effect takes on new light under this lens. Those collective misrememberings where groups swear Nelson Mandela died in prison or the Monopoly man wore a monocle could be artifacts of the simulation being rolled back and rerun with slight variations. The famous double-slit experiment in quantum mechanics, where particles behave differently when observed, mirrors how video games reduce rendering detail for areas outside the player's view. This isn't just philosophical noodling. Billion-dollar experiments like CERN Large Hadron Collider are essentially probing the source code of our universe, searching for pixelation in space-time at the Planck length. Some theorists suggest that if we're in a simulation, we might uncover evidence like mathematical rounding errors in physical constants or cosmic ray particles with impossible energies, artifacts of the simulation's processing limits. The darkest implication: if our creators can freeze or rewind time locally, their motives become terrifyingly opaque. Are entropy fields diagnostic tools, or are we lab rats in a cage where the experimenters occasionally stop time to take notes? The cosmos' accelerating expansion could be their way of isolating simulation instances to prevent cross-contamination. Even the Fermi paradox, the eerie silence of the universe, might have a simple explanation. They paused all other civilizations to focus on observing us. Yet there's an oddly comforting angle too. If simulation theory holds, the very existence of entropy suggests intentionality. In pure chaos, there'd be no arrow of time at all. The fact that disorder increases predictably could indicate the simulation is designed to self-clean, preventing memory overload. Those frozen moments might not be glitches, but necessary system reboots, cosmic deep breaths before the next frame renders. Ultimately, whether we're in a simulation or not, the idea reshapes how we view entropy. It's no longer just a thermodynamic inevitability, but a potential signature of deeper architecture. And if alien entropy fields exist, they might not just control time, they could be the brushstrokes of beings so advanced. Their technology is indistinguishable from the laws of physics themselves. Freezing time might sound like the ultimate power fantasy until you realize it comes with ethical burdens heavier than a black hole's pull. The moment you pause reality, you're not just pressing a cosmic pause button. You're making a choice about who gets to move and who stays frozen, who benefits and who suffers. Picture a world where a single entity controls this ability. Would they use it to stop a nuclear meltdown or to freeze political dissidents mid-protest? The line between hero and tyrant blurs when time itself becomes a weapon. Consider the most altruistic scenario: preventing disasters. A tsunami surges toward a coastal city milliseconds before impact. An entropy field activates, freezing the wall of water into a grotesque sculpture. Rescuers now have infinite time to evacuate everyone, but here's the catch: what defines a disaster worth stopping? A hurricane, a stock market crash? An assassination? Once you start arbitrating which moments deserve intervention, you've become judge, jury, and cosmic editor. And history isn't just a series of tragedies. The same earthquake that levels a city might unite survivors into building something stronger. Intervene too often, and you risk creating a brittle world that never learns to adapt. Then there's the darker temptation: rewriting history. Imagine freezing time during a pivotal battle, subtly repositioning soldiers to alter the outcome. Sounds noble until you realize every correction erases countless lives that would have existed in the original timeline. The ethical quagmire deepens when you consider ripple effects. Save a president from assassination, and you might prevent a future peace treaty. Stop a plague, and you could inadvertently stifle medical breakthroughs born from desperation. Time isn't a straight line you can tweak without consequences. It's a web where every thread, no matter how frayed, supports the whole structure. The cosmic perspective is even more unsettling. Entropy isn't just a physical law, it's the engine of existence. Stars die so planets can form. Civilizations collapse so new ones can rise. If an advanced species started routinely freezing entropy, would they unwittingly starve the universe of renewal? Indigenous philosophies often speak of balance, of death making room for life. Western science echoes this with thermodynamics. Energy must disperse for work to happen. A civilization that halts entropy might be like a child damming a river, not realizing they're poisoning the downstream ecosystem. But the most chilling dilemma lies in consent. Freezing time for a planet means making decisions for every living thing on it without asking. Is it ethical to pause a farmer in mid-step, a bird in mid-song, a child mid-laugh, even if the reason is benevolent? We debate the ethics of uploading human minds to computers, but at least that requires individual choice. Time manipulation imposes stillness universally. The frozen might not even know they were paused, or worse, they might be aware, trapped in an endless instant like a nightmare where you scream but no sound escapes. Perhaps the greatest irony is that the very act of controlling time could destroy what makes humanity human. Our morality is built on urgency, the knowledge that moments pass, that choices matter because they're irreversible. Remove that, and compassion might calcify into calculation. Why rush to heal the sick if you can freeze their illness indefinitely? Why reconcile with loved ones if you can pause conflicts before they escalate? A world without time's pressure could become a world without growth, without forgiveness, without the raw, beautiful mess of being alive, the terrifying truth. There's no ethical handbook for wielding powers that rewrite reality's rules. Alien civilizations might have grappled with these questions for eons, arriving at answers we can't yet fathom. Or perhaps they learned the hard way that some forces aren't meant to be controlled, that time, in all its relentless flow, is the one teacher even gods must kneel to. After all, the universe gave us clocks, not pause buttons, and that might be the kindest design of all. Numbers don't lie, but what if they're hiding something? Scattered throughout the equations that govern our universe are numerical constants so precise they seem almost intentional. The gravitational constant, the speed of light, the fine structure constant, these aren't arbitrary values. They're the foundation of reality's code, yet some physicists speculate these numbers might be more than just cosmic rules, they could be signatures. Imagine an advanced civilization encoding instructions for entropy manipulation directly into the fabric of physics, leaving breadcrumbs in the digits only a species ready for the knowledge could decipher. Take the fine structure constant, approximately 1/137. This dimensionless number dictates how light interacts with matter, and it's so finely tuned that even a slight change would prevent stars from forming. But look deeper. Mathematicians have found peculiar patterns in its digit sequences that mirror prime number clusters and geometric ratios found in ancient megaliths. Coincidence, maybe, but what if it's a marker, a way of saying, here's how to bend the rules? Then there's the wow signal. In 1977, Ohio State's Big Ear radio telescope detected a 37-second burst of radiation from the Sagittarius constellation. The signal was 30 times louder than background noise, matched no known celestial object, and has never been repeated. Astronomer Jerry Amon circled the printout with red ink and wrote, "Wow." Beside it, and the name stuck. Most scientists dismiss it as a passing anomaly, but the signal's frequency, 1,420 MHz, is eerily significant. That's the hydrogen line, the resonant frequency of the universe's most abundant element, a perfect calling card for any civilization wanting to be heard. But the real mystery lies in the signal's structure. Analysis suggests it wasn't random noise. Its intensity rose and fell in a way reminiscent of pulsed coding, precisely the method we'd use to send data across interstellar distances. Some researchers, like Dr. Antonio Paris, propose it might have been a directed burst, a fleeting test transmission from a probe or relay. Others wonder if it carried embedded information, perhaps even the mathematical blueprint for spacetime manipulation. If so, we might have missed the message not because it wasn't there, but because we lacked the key to read it. Even stranger are fast radio bursts, or FRB cosmic blips lasting milliseconds that pack the energy of 500 suns. Some repeat at irregular intervals, others just once. But in 2020, scientists detected an FRB from 3 billion light-years away with a 90-day cycle, like a celestial metronome. The odds of such perfect periodicity occurring naturally, astronomer Avi Loeb put it bluntly, suspicious. Could these be navigation beacons for civilizations hopping between entropy-controlled zones? Or worse, the remnants of ancient experiments gone wrong, puncturing spacetime with predictable scars. the most haunting possibility: we're surrounded by signals we can't yet recognize. In 2015, the Breakthrough Listen project detected repeating narrowband radio pulses from Proxima Centauri. These matched no known natural source and exhibited Doppler shifts suggesting orbital motion, as if emanating from a planet. Yet the signals vanished before confirmation. It's a pattern, cryptic messages flickering at the edge of perception, always dissolving into noise before we grasp their meaning. Perhaps the truth isn't in the signals themselves, but in their absence. The cosmos should be teeming with chatter if life is common. Instead, we get whispers, like a game of cosmic hide and seek where the rules are written in math we don't yet understand. If alien entropy fields exist, their creators might not broadcast instructions outright. They could leave them buried in constants, waiting for us to evolve enough to ask the right questions. After all, the universe doesn't keep secrets. It waits for us to learn the language. From the silver screen to the pages of comic books, the idea of freezing time has captivated storytellers for generations. But how do these fictional portrayals stack up against the hard science we've explored? Take The Matrix, where Neo dodges bullets in suspended slow motion. The film frames this as a digital glitch, a momentary hiccup in a simulated reality. While our universe isn't a computer program as far as we know, the concept mirrors quantum physics' observer effect, where particles behave differently when measured. Neo isn't just stopping time, he's rewriting the rules of his perceived reality, much like an advanced civilization might manipulate entropy fields to alter local physics. Then there's Doctor Strange, where the Sorcerer Supreme traps adversaries in looping time pockets. The movie handwaves this as mystic arts, but the mechanics resemble theoretical closed time-like curves, regions where space-time bends into a loop, reliving the same moment indefinitely. In the real world, physicist Ron Mallett's work on laser-induced time loops suggests such phenomena might not be pure fantasy. The key difference: magic spells versus precision-engineered space-time warps. Games like Superhot take a more interactive approach, where time moves only when the player does. It's a clever metaphor for consciousness's role in shaping perceived reality, echoing quantum biology theories that link observation to entropy's flow. Contrast this with The Legend of Zelda, Majora's Mask, where a 3-day time loop forces players to relive cycles until they solve key events. The game's mechanics unintentionally illustrate entropy's stubborn persistence. No matter how much you rewind, certain outcomes remain inevitable unless you alter their underlying causes. But fiction often glosses over the brutal consequences. Click with Adam Sandler treats time stopping as a comedic shortcut, skipping life's mundane moments. The dark twist that fast-forwarding through pain means missing growth hints at a deeper truth. Entropy isn't just a physical process, it's tied to experience itself. Meanwhile, Edge of Tomorrow's time-looping protagonist retains muscle memory across resets, a nod to quantum states preserving information even in altered timelines. The most chilling depiction might be Twilight Zone's, a kind of stopwatch, where freezing time strands the protagonist in eternal isolation. No sound, no movement, just the horror of being alone in a static world. This aligns with neuroscientific fears about consciousness trapped in entropy-stalled biology. Fiction's flair for drama aside, these stories grapple with the same ethical and physical dilemmas physicists face: the cost of cheating time and the unintended chaos of tampering with causality. Where pop culture stumbles is in the aftermath. Rarely do characters wrestle with frozen photons mid-air or the thermodynamic fallout of paused chemical reactions. Interstellar comes closest, showing time dilation's emotional toll but still simplifying the astrophysics. Yet these creative liberties serve a purpose. They let audiences feel the concepts before understanding them. After all, science needs equations, stories need stakes, and somewhere between the two lies the tantalizing possibility that our favorite time-bending tales might be closer to truth than we think. Betty and Barney Hill's story isn't just one of the most well-documented UFO encounters, it's a chilling case study in time's unsettling flexibility. On a quiet September night in 1961, the couple was driving through New Hampshire's White Mountains when a strange light tailed their car. What followed were 2 hours they couldn't account for, a stretch of missing time that only surfaced under hypnosis. Their recovered memories painted a surreal scene, being taken aboard a craft, examined by beings with wraparound eyes and subjected to tests they didn't understand. But the most unnerving detail, Barney's wristwatch stopped working that night, its hands frozen at the exact moment the UFO appeared. When they finally arrived home, their car's trunk bore odd circular markings, and Betty's dress was shredded in ways she couldn't explain. Coincidences pile up until you consider the physics. What if their missing hours weren't erased but paused? Modern quantum theory allows for localized space-time distortions where entropy's flow could be temporarily suspended. Think of it like a cosmic eddy in time's river. The Hills might have entered a region where entropy was deliberately manipulated, slowing their perception while the outside world rushed forward. Their watches didn't malfunction, they were reacting to a field where atomic vibrations, the very heartbeat of timekeeping, were suppressed. Even their fragmented memories align with how consciousness behaves under extreme time dilation. Neurons firing in altered entropy conditions could scramble recall like a tape recorder jammed in playback. They weren't alone. In 1975, logger Travis Walton vanished for 5 days during a UFO encounter in Arizona. His crew swore they saw him struck by a beam of light before the craft sped away. When Walton reappeared, dehydrated and delirious, he described waking aboard the UFO surrounded by eerie figures. But here's the twist: from his perspective, only hours had passed. His body's dehydration suggested otherwise time had moved differently for him than for everyone else. Skeptics cry hoax, but Walton's radiation burns and the crew's polygraph past testimonies hint at something stranger. If entropy fields can stretch or compress time's flow, Walton might have been caught in an asymmetrical bubble where his biological clock ticked slower than Earth. Then there's the lesser-known case of police officer Herbert Skirmer in 1967. After spotting a hovering craft in Nebraska, he experienced a 20-minute blackout. Under hypnosis, Skirmer recalled being paralyzed by a beam, then taken aboard where humanoids in metallic suits showed him flickering screens displaying Earth's energy lines. When he returned to his patrol car, the engine was cold, impossible after just 20 minutes of idling. This detail mirrors the Ural's frozen forest incident, sudden, unexplained heat loss consistent with entropy suspension. If the craft generated a localized time stasis field, the engine's thermal energy transfer would have halted mid-process, leaving metal colder than physics should allow. The common thread: these encounters don't just distort time, they redistribute it. Like a video editor splicing frames, the phenomenon seems to cut and reorder moments with precision. Missing time might not be erased, it could be stacked elsewhere, compressed into perceptual blind spots. This aligns with theoretical models of quantum superposition, where particles exist in multiple states until observed. Scale that up to macroscopic levels, and you've got a recipe for reality edit so seamless. Witnesses only notice the seams when their watches disagree with the sky. Critics argue these cases are just stress-induced memory lapses, but that fails to explain the physical traces: radiation burns, stalled engines, corrupted film. Something tangible interacts with these witnesses, something that leaves entropy's fingerprints all over the scene. Maybe the UFOs aren't spacecraft at all. They could be mobile entropy field generators, devices that tweak time's dials for purposes we can't yet fathom. After all, if you had technology that could freeze reality around you, wouldn't your movement seem impossibly fast to outside observers? Wouldn't your appearances and disappearances look like magic? The Hills, Walton, Skirmer, they might have brushed against a technology that treats time as a variable, not a constant. And if that's true, their stories aren't just about alien encounters. They're accidental reports from the frontier of a physics we're only beginning to dream of. Picture a world where the relentless march of time isn't just slowed, it's stopped on command. A scientist presses a button in a lab in Zurich, and across the globe, raindrops hang motionless above Tokyo, stock market tickers freeze mid-scroll on Wall Street, and a child's laughter lingers in the air like an unbroken chord. This isn't magic, it's the hypothetical future where humanity cracks the code of entropy fields. But with such power comes a fork in civilization's road, one path gleaming with possibility, the other shrouded in existential shadows. On the utopian horizon, medical stasis pods erase terminal diagnoses overnight. Cancer patients could pause their disease's progression indefinitely while researchers work on cures, no more racing against biological clocks. Climate disasters become manageable as entropy fields contain wildfires mid-blaze or freeze rising floodwaters long enough to evacuate entire cities. Archaeologists might study ancient artifacts in pristine condition. Their decay halted the moment they're unearthed. Even space travel transforms. Astronauts crossing interstellar distances could suspend their perception of time, arriving at Proxima Centauri feeling like the journey lasted minutes rather than centuries. The very concept of too late vanishes from our vocabulary, yet beneath this glittering surface lurk dystopian landmines. Imagine a society stratified by access to chronotechnology, where the wealthy buy eternal youth in private time vaults while the poor age normally, creating an unbridgeable class divide. Governments could weaponize entropy fields, freezing dissenters in perpetual stasis without trial or deploying time-stop drones that strike before targets blink. Darker still, what happens when someone activates a field recklessly? A single uncontained entropy bubble might expand exponentially, freezing continents before anyone realizes the mistake. Historians warn how new technologies often amplify existing inequalities. Fire warmed homes but also burned cities. Nuclear power lights metropolises but leveled Hiroshima. The psychological toll could prove just as devastating. Human culture thrives on rhythms, seasons changing, children growing, stories having beginnings and ends. In a world where these cadences can be paused at will, would we still cherish moments knowing they're no longer fleeting? Studies on near-immortal jellyfish show that without death's pressure, evolution stalls. Might our creativity wither if deadlines become meaningless? The very trauma of witnessing frozen loved ones, preserved yet unreachable, could spawn new forms of temporal grief we can't yet comprehend. Perhaps the most unsettling question isn't whether we'll develop this technology, but whether we'll recognize ourselves after using it. Time isn't just a measurement, it's the invisible hand shaping our humanity. To remove its pressure might be less like removing chains and more like removing gravity. Everything would float aimlessly, unmoored from the forces that gave it meaning. The ancients feared Prometheus for stealing fire, but mastering time, that's stealing the clockwork of the cosmos itself, and some doors once opened can't be closed. The moment humanity unlocks entropy field technology, the geopolitical chessboard gets flipped, not just for one nation, but for every living thing on Earth. Imagine a world where the first country to master time control could freeze global markets mid-transaction, suspend rivals' nuclear arsenals indefinitely, or lock entire populations in stasis during negotiations. The stakes dwarf the nuclear arms race by orders of magnitude. Unlike splitting the atom, which required uranium and colossal infrastructure, entropy manipulation might only need a room full of quantum computers, technology already proliferating globally. The barrier to entry could be shockingly low and the consequences of unregulated use catastrophic. This isn't speculative fiction. History shows how technological leaps outpace governance. When the Wright brothers took flight in 1903, no international air traffic laws existed. By 1914, planes were dropping bombs in World War I. The lesson: science moves faster than diplomacy. To avoid a time manipulation free-for-all, we'd need something unprecedented, preemptive global cooperation. Think the International Atomic Energy Agency, but for chronoethics, a consortium of physicists, ethicists, and policymakers working now before the breakthrough happens to draft frameworks. Where would they even start? First, transparency thresholds. Any lab achieving localized entropy suspension must immediately notify a neutral body like CERN or the United Nations Office for Outer Space Affairs. The Cold War's hotline agreement proved direct communication channels prevent escalations. Now apply that to time-altering tech. Second, non-weaponization treaties. The Outer Space Treaty of 1967 banned nukes in orbit. A chrono accord could prohibit deploying entropy fields in warfare, with verification measures like quantum signatures to detect illicit use. But enforcement gets murky fast. Unlike nuclear tests, entropy experiments might leave no radiation signature or seismic footprint. A rogue nation could test frozen time bubbles in underground labs undetectable by satellites. Here's where cutting-edge verification comes in. Quantum entanglement networks like China's Misha satellite could act as tamper-proof monitors. If particles in a distributed sensor network suddenly stop decohering, it might signal a localized time halt. The ethical quagmire deepens with civilian applications. Should corporations be allowed to patent entropy suspension? A pharmaceutical giant could charge millions to pause degenerative diseases, creating a two-tiered system where only the wealthy buy immortality. Or consider cultural preservation. Freezing the Amazon rainforest's entropy to halt deforestation sounds noble, but what about indigenous communities living there? Their consent would be non-negotiable. UNESCO World Heritage Protocols offer a model prioritizing stewardship over ownership. Perhaps the most urgent need is a fail-safe protocol. All technology fails sometimes catastrophically. If an entropy field generator malfunctions, could it freeze time irreversibly in an expanding radius? The Large Hadron Collider implemented similar safeguards after doomsday fears about micro-black holes. Future labs might require chrono-circuit breakers, quantum triggers that collapse an entropy field at the first sign of instability. Scientists can't shoulder this alone. Public engagement is crucial to prevent panic. When CRISPR made gene editing mainstream, the global science community held town halls and citizen juries to demystify the tech. The same grassroots approach must happen now, educating societies about entropy's double-edged potential before conspiracy theories fill the vacuum. The clock is ticking ironically on preparing for a world where clocks might stop. Whether entropy fields remain fiction or become fact, one truth holds. In the race between human ingenuity and human wisdom, wisdom has never needed a bigger head start. We stand at the edge of a cosmic frontier, peering into a mystery that rewrites the rules of reality itself. Alien Entropy Fields Technology isn't just a sci-fi dream. It's a scientific possibility lingering in the equations of quantum physics, whispered in the anomalies of our universe, and etched into the myths of ancient civilizations. The evidence isn't just in the frozen forests of the Urals or the missing hours of UFO encounters. It's woven into the fabric of space-time, waiting for us to decode its secrets. Think of what we've uncovered: black holes that twist time like taffy, quantum particles that rewind their own decay, and civilizations that might have mastered these phenomena eons before we even existed. The implications are staggering. Time isn't just a river, it's a canvas, and somewhere in the cosmos, others might be painting on it. But for all we've theorized, the biggest questions remain unanswered. Who's using this technology? Are they benevolent guardians freezing disasters, or unseen architects molding reality to their will? And most hauntingly, are we part of their experiment? This is why the hunt matters. Every unexplained anomaly, every glitch in the clockwork of the universe could be a clue. Maybe the truth lies in the next breakthrough at CERN, or in the forgotten archives of an ancient culture, or even in your own backyard. The universe doesn't give up its secrets easily, but that's what makes the search so thrilling. So stay curious. The day we finally crack the code of entropy fields might rewrite everything we know about existence. Until then, the mystery is yours to explore. Dive into the comments and tell us what's your wildest theory about time-stopping technology. And if you're hungry for more cosmic enigmas, hit subscribe. The universe is stranger than fiction, and we're just getting started, because here's the thing about time. It might not be what we think, but one day we might just bend it to our will or discover something out there already has.